This video is all about application problems for linear equations and solving those, kind of making models for these types of problems and then solving them. So this first problem says a consumer purchased a computer for 27% price reduction. If X is the original price, what's the reduced price? So if it's a 27% price reduction, if it was reduced by 27%, that's 27% taken off of 100%, which is the full price. So the new price reduction, or the percentage that it actually was, is 73%. It costs 73% of its original price. If the original price is X, then that means this 0.73 times X is the new price of the computer. Of course, once we know what X is, we can just plug it into there and calculate, and we'll get the new price. The combined yearly interest for X dollars invested at 13% and 20,000 minus X dollars invested at 8% is what? So once again, we cannot find an exact amount because we don't know what is the actual dollars that were invested. However, we can write an expression that tells us how to compute it. All we have to do then is plug in X and then use order of operations. So if X dollars are invested at 13%, then that means 0.13 times X is how much interest the account gives after a year. Then we add that to however much is obtained after a year from the next account, which is going to be 0.08. We never use percentages in mathematics. We always use a decimal representation of it. And this is going to be times how much dollars, or how many dollars are invested at that rate, which is going to be 20,000 minus X. And this is the interest that you gain after a year from these two accounts. All you have to do is plug in X and you can figure out the exact amount of interest gained. This is less of an application problem and more of understanding how to do algebraic manipulation. So if we're trying to solve for I, meaning we need to get I by itself. And right now, there's two I's in this equation. We have to have only one to solve for it. So how do we get the I's by themselves? Well, IR plus I big R times R plus I little r equaling E. Think of, let's think of it like this. Let's say R equals 4 and little r equals 2. Then we have I times 4 plus I times 2 equals E. And I can rewrite this as 4I plus 2I equals E. Well, now it should be quite simple to see what we do. 4I plus 2I, these are like terms. 4 plus 2 is 6I equaling E. I can write this as 4 plus 2I equaling E. And I can go backwards using the equations I gave in the very beginning. 4 is just big R. We get R plus little r, I equals E. This is a long drawn out way of saying that what I can do in this very first position here is I can factor out an I. I can take out an I and I put it on this side. It doesn't really matter which side you go on. Right? I could say I equals R plus RE. And you can see that this is true by just distributing the I back in. We get IR plus IR equals E. But that's the same thing we started with. So that's how you know what the first step is. Very important trick when you're doing algebra, because sometimes you have two variables. For instance, 3x plus xy equals 4. To solve for x here, you have to factor out the x, which then you can divide by the 3 plus y. That's how you solve for the x. That's the actual method of doing it. Here we have 2 gym memberships with a sign-on fee and a monthly fee. And we're asking how many months will the total cost of each membership be the same, and then what's the total cost. This is going to actually give us a equation that we can solve, and we can actually find things about this. So this is going to be more like a linear equation that we're actually going to do things with. So let's look at Gym A. It's a sign-on fee of $18 plus a monthly fee of $27. Let's say the months that you joined is M. You always have to have a variable for these types of problems. So it's important to see what's the thing that's changing. And the changing thing here is the month, right? If you're there for 10 months, you pay, however much for that. If you're there for 24 months, well, then you pay a lot more for that. So M is going to be the number of months. You can say like after joining, or just say the number of months. Yeah. Now we can look at Gym A. What's the membership fee when you've gone to the gym for M months? Well, there's a sign-on fee of $18, so we know there's going to be a flat $18 fee. So if you went there for no months, it'd be 18. If you went there for 1 month, it would be 18 plus 27, because that's the monthly fee. If you went there for 2 months, it would be 18 plus 27 times 2. For 3 months, it would be 18 times 27 times 3. Now you should see a pattern forming here. This is just the months that you've gone to the gym, which means this thing is going to be 18 plus 27 times M. That's the actual algebraic expression, just to find out how much it would cost. Likewise, we can do this for gym membership B, right? The sign-on fee is $26 plus a monthly fee of $23. Now, we have 2 expressions. This is going to be Gym A. This is Gym B. And the actual question says, after how many months will the total cost of each membership be the same? In other words, when does Gym A equal Gym B? When those memberships equal each other? Now all we have to do is solve for M. And this is a linear equation with one variable. We just need to get M by itself to solve. I'm going to do so by subtracting 23M on the right-hand side. That gives me 18 plus 4M equals 26. Then subtract 18 to the other side. That gives me 4M equals 8. And of course, divide by 4. We say M equals 2. So after 2 months, both gym memberships will be the same. Then it asks, what is this total cost after 2 months? Since they're both the same, it doesn't matter which expression you plug 2 into, Gym A or Gym B. They should both give you the same number, because that's the whole point of setting them equal to each other. I'm just going to do 18 plus 27 times 2. Gives me 18 plus 27 times 2 is 54. And 54 plus 18 is $62.72, I believe. So after 2 months, they give you the same price point, and that price point is $72. That's how much you would have paid. After an 85% reduction, a drying machine is on sale for $87. So after the reduction, the new price is $87. What was the original price? Well, we can use the same ideas that we used in that previous problem about the consumer buying the computer. We're going to find an expression that gives us the original price in terms of the new reduction. So if 100% was the original price, and we have an 85% reduction, and we just subtract it from there, and that gives us 15%. That means the dryer is 15% of what it originally costed. So the original price is going to be 15% of X. Now you could say original price, you could give any variable to this. I'm just going to say the original price is X. That's what we're trying to find. That's the unknown here. It's the same thing in the previous problem with the gym memberships, right? We're trying to figure out what the unknown was the months. That's what we wanted to know. We didn't know what it was, so we gave it a variable. Here, we want to know what the original price is, so we're going to give that a variable, X, and we're going to start writing an equation that represents X. Now, 15% of X, this is the new price, and the new price said it was $87. So 0.15x equals 87. To find what the original price is, all we have to do is divide by 0.15. And that gives us $580. That was the original price of the drying machine. We've got two accounts that we're investing in. They give us different annual interests, and we know we want a total interest earned of $12.80. So how much should we invest in each account to get that total interest to earn? Well, what's the interest that comes from the first account? Well, we don't know how much is in the first account, so let's give that the variable X. Now, if X was plugged into the first account, then how much was plugged into the second account, which is 9%? Well, if X is plugged into the first account and you're completely investing $18,000, then plugging into the second account is going to be taking away X dollars from 18,000, right? So we get 18,000 minus X. X plus 18,000 minus X gives you 18,000. So that's the total amount that you invested. Okay, how do we find how much interest is earned in the 7% account that we invested X dollars at? That's just going to be 7% of X. That's how much invested, how much interest comes after a single year. Now, if we add that to how much we get from the second account, which is 9% of the dollar amount that we invested at, which is $18,000 minus X. This is going to be our total interest that we've earned after a single year. And it says if the total interest you earned that you want to earn is $12.80, how much do you have to invest at each rate? Well, all we have to do is set this equal to $12.80, and we can find how much we invest into each account. This is a linear equation with one variable. That means we can actually get a solution here, as long as it doesn't give us no solution, but that shouldn't happen. Okay, let's distribute this 0.09. 0.09 times 18,000 gives us 1620. Now, these are like terms that are on the same side of the equation, so I can combine them. 0.07 minus 0.09 is negative 0.02. And I can subtract 1620. $16.20 gives us negative 340. We, of course, divide by negative 0.02 to both sides. And that gives us $17,000, it looks like. Okay. Now, X equals 17,000, and we said that X is the amount of money that's invested at 7%. And how much then do we invest in the 9%? Well, we take 18,000 minus X, X is 17,000, which means we invest $1,000 in the 9% interest. 17,000 in the X and the 7% interest, 1,000 in the 9% interest. That's how much was invested at each rate. Okay, this one's got a nice visual. I recommend drawing a picture whenever you can. A lot of times it can help out. Sometimes it doesn't, but a lot of times it does. A rectangular field looks like this. It's twice as long as it is wide. So if the width is the smaller dimension and the length is twice as long as it is wide, that's going to be 2W. Then it says, what are the dimensions of the field if the perimeter is 180 yards? Well, the perimeter is just adding up all of the side lengths. So we have W plus 2W plus W plus 2W. That's the perimeter. And that's going to equal 180 yards. So W plus 2W plus W plus 2W equals 180. That's because both the opposite sides of the triangle, the rectangle I should say, are the same length. And that's how you find the perimeter. You just add up all of the side lengths. Well, these are all just like terms. W plus 2W is 3W, plus W is 4W, plus 2W is 6W. Divide by 6. You get that the width equals 30. And 180 was in yards, so 30 is going to be in yards. And if W is 30, then 2W is 60 yards. So it's a 60 by 30 yard rectangular field. The job's annual salary is $33,725 with a holiday bonus of $725. The paychecks are twice a month. What's the gross amount of each paycheck? Well, we're trying to figure out what's the amount of each paycheck. The amount of each paycheck is going to be, I'm going to say P here because P for paycheck. I'm going to give that the variable because that's what we're looking for. If paychecks are twice a month and there's 12 months in a year, that means that he got paid, well, he or she got paid 24 times, and each time was the amount on the paycheck, which is the P variable that we said. Now, this isn't the only thing they got paid, right? Because they also got a holiday bonus of $725. So 24 times P, this is the amount that they actually got on the paychecks. That's the bi-weekly paycheck they got. And 725 is the amount at the end of the year that they got for a holiday bonus. This is the total amount that they received for their salary. And this equals, well, the annual salary that's been received, $33,725. This is a linear equation with one variable, which means we can solve it by just getting the variable by itself. So subtract 725 from both sides. We get 33,000, and we divide by 24. So each paycheck was $13.75. This, of course, is in dollars. All right, the last few are less about applications and more about solving formulas, as they're called. This is a formula. It's not really a linear equation, but you solve it kind of the same way. We're going to solve this equation for f. C equals 1/2 f times n. We're solving it for f, so we want to get f by itself. There's a lot of different ways you can do this or think about doing it. You could divide by 1/2 in n. You could multiply by 2, divide by n. It's fastest to do it all in one step. If I divide both sides by 1/2 n, what you see here is that the 1/2s cancel and the n's cancel. And that leaves us with f by itself, which means we've solved for f. and we just leave it on the other side as what's given here. Now, of course, you have a division by a fraction. You could say, well, we can multiply by the reciprocal. The reciprocal of 1/2 is just 2 over 1, right? But 2 over 1 just equals 2. And we're multiplying by that. So you could say that this just equals 2c over n. Either one of these is really the same thing. The 2c over n, that's a cleaner way of writing it. But you can get that by just multiplying the first equation by 2, because that also cancels with the 2. There's lots of different ways of doing these types of problems. Just get the variable by itself using proper algebra, and try and simplify it if you can. That's what I would recommend. All right, here's another one. This one we solve for the equation 2 different ways. We're going to solve the first one for t and the second one for m. I'm going to solve this for t first. I need to get t by itself, and you start by getting rid of the secondary term. In the previous problem, we didn't have any additional terms. They were all multiplying each other. But here we have an addition. So we need to get rid of the other term first. You always have to do that. It's going to make the mathematics a lot easier. It gets very, very weird when you don't do it that way. Now, to get t by itself, all we have to do is divide by mr, because mr are multiplying t. And now we have t by itself. You could do it individually, right? You can divide by m, and then divide by r on both sides. And that'll get you the same thing. Okay, now we have solve for m. And this, you can see that we have 2 m's here. We need to only have 1 m. To do this, we need to factor out the m, just like in that previous problem with the I, capital R, lowercase r. We're going to factor out the m. M divided by m is 1. MRT divided by m is RT. And now it's quite easy to see what we have to do here. M is multiplying this quantity, which we don't want. We're just going to divide out that quantity. Now we have m equals a over 1 plus RT. M is by itself, so we have just solved for m.